So this is example 5.4.2, and this is one of the most common questions we get. They say, okay, well, wait a second, what is the opposing force of gravity? And it's kind of a confusing answer. So if you look at it, let's say you jump off the surface of the earth. So you've got some sort of distance. Let's say you're skydiving. Let's say this is something like 1,000 meters. There is a definite gravitational pull that the earth is exerting, pulling you down to the surface of the earth. But the question is what is the equal and opposite force? And the equal and opposite force may be somewhat confusing, is the fact that there is an opposite force or a gravitational force of you pulling the earth upwards. So let's say that you have a mass of 100 kilograms, just to make it easy. If you have a mass of 100 kilograms, there's actually a 980 Newton force downward pulling you down. Likewise, there's a 980 Newton force that you exert pulling the earth up. Now the question I usually get is, well, wait a second, if I jump and that's exerting a force on the earth, does the earth move? Well, remember we did this calculation earlier with a boy and saying, okay, well, force is equal to mass times acceleration. Remember, if I pull the earth with a force of 980 newtons, it all depends on the mass right here to determine my acceleration. Well, just to let you know, 5.98 times 10 to the 24th is the mass of the earth, which is a 5, a 9, an 8, and then 22 zeros after it. So you can see that the acceleration value would be very, very, very small.